Starlink's magic isn't about new inventions, so what if Russia's doing it smarter? Here's a secret few in the West want to admit. Starlink isn't built on radical new tech. Its core is decades old. Some of its foundational technologies go back 30 to even 60 years. The real genius of Elon Musk isn't inventing from scratch, but scaling up, integrating, and flooding the market with these mature solutions. Throwing money and manufacturing muscle at old ideas made Starlink a household name. But is that true innovation? Now Russia is stepping into the game with Rassvet, not as a Starlink copycat, but as a genuine next step in satellite internet. With a fundamentally different approach, fewer satellites, higher orbits, and advanced tech integration, Rassvet could flip the script on what global connectivity looks like. Miss this, and you're missing where the future of communication and technological power could actually go. So, how does Starlink truly work, and why might Rassvet be a leap ahead? Let's break it down. Starlink is a masterclass in remix, not reinvention. While the headlines paint it as a technological leap, the truth is more nuanced, and honestly, more fascinating. The real genius of Starlink lies in how it stitched together tried and true technologies, scaled them up, and made them affordable for the first time in history. Let's break it down. The idea of using low Earth orbit satellite constellations isn't new. Iridium did it back in 1998, with a network of LEO satellites offering global phone coverage, but at a high cost and bulky gear. Then there's the phased array antenna, a technology military radars have relied on since the 1950s. What's different now? Starlink adapted it into a mass-market, low-cost, and compact user terminal that can automatically find and track satellites overhead. Basically, radar tech brought into your backyard. Laser inter-satellite links? Those sound futuristic, but experiments started in the 1980s and 90s with agencies like NASA and the Soviet Union. The real trick was making them standard, reliable, and cheap, something Starlink nailed with its later satellite versions. And then, mass satellite production. SpaceX borrowed strategies from car factories and electronics assembly lines, standardized designs, assembly lines, and minimal manual labor. This slashed the price of each satellite from hundreds of millions to just a few $100,000, a game changer. Even the frequencies and protocols Starlink uses are decades old, adapted from satellite TV and terrestrial digital networks. And the whole concept of a mega-constellation? That's been in technical papers since the 1990s. So why didn't it happen sooner? The tech and the economics just weren't ready, until now. Here's why this matters. Misunderstanding where real innovation happens could mean backing the wrong horse or writing bad policy. But what makes Starlink successful isn't the tech itself. Let's see what really set it apart, and where its limits show. Rassvet isn't following, it's rewriting the playbook. While everyone's been focused on Starlink as the gold standard, Russia's Rassvet project took one look at the crowded low Earth orbit lanes and said, "Let's do things differently." See, by the time Rassvet got the green light, those sweet spot orbits at 500 to 550 kilometers were already packed with Western satellites. Instead of cramming in more hardware, Rassvet made a bold move. Push higher, to about 800 kilometers above Earth. Now, you might think that's a disadvantage. Farther away means more latency and weaker signals, right? But here's the twist. At that altitude, each satellite sees a much larger chunk of the planet. That means fewer satellites are needed to provide the same global coverage. Where Starlink needs a mind-boggling 10,000 satellites, each about 200 kilograms, Rassvet is aiming for just 300 to 500. But these are bigger, heavier, and vastly more powerful machines. Instead of the Starlink model, more satellites, simpler hardware, Rassvet has chosen fewer satellites, each packed with advanced tech. This is a radical trade-off. Fewer satellites mean lower launch and maintenance costs, but each one becomes more critical. If one goes down, it's a bigger deal. Still, with smart engineering, this could leapfrog Starlink's brute force approach by betting on quality and strategic autonomy rather than sheer numbers. And while Starlink only recently began integrating laser links for satellite-to-satellite communication, Rassvet makes this advanced tech a baseline. Every satellite will relay data with infrared lasers, promising faster, more secure global links. Rassvet's next-gen laser links start at 10 gigabits per second, and the network aims for up to 1 to 3 terabits per second across the whole constellation. A serious upgrade, especially considering the smaller fleet. Of course, there are trade-offs. Rassvet's ground terminals are heavier, about 15 kilograms compared to Starlink's sub-2 kilo units. That's the price of talking to satellites almost twice as far away. But the promise? Up to 1 gigabit per second for users, which could be a game-changer if it delivers. So, is this a brilliant leap ahead or a risky bet against the prevailing wisdom? The answer comes down to performance, economics, and the shifting balance of power. And that's what we'll unpack next. What happens when fewer, smarter satellites change the rules? That's exactly what Russia's Rassvet project is betting on. By placing satellites in higher orbits, about 800 kilometers up, each one can cover a much bigger area than Starlink's low-flying swarm. But there's a trade-off. Higher up means you need more powerful antennas, and the ground terminals get bulkier. Rassvet's current terminal weighs about 15 kilograms, way heavier than Starlink's dish. Still, the promised data speeds? Up to 1 gigabit per second, with latency around 70 milliseconds, remarkably close to Starlink's real-world performance. Here's where it gets really interesting. While Starlink relies on sheer numbers, over 10,000 satellites launched, mostly under 300 kilograms each, Rassvet is aiming for quality and integration. The backbone is next-gen laser links between satellites. Starlink's already running thousands of laser interlinks, hitting up to 200 gigabits per second per connection. Rassvet's initial laser links start lower, but the target is up to 1 to 3 terabits per second, because with far fewer satellites, each one has to move a much bigger chunk of data. And Rassvet has another card to play. 5G NTN, or non-terrestrial networks. This means, in theory, your phone could connect directly to a Rassvet satellite, bypassing bulky terminals entirely. Early tests already happened in 2024. The vision? Direct device-to-satellite links, plus possible future layers, like ultra-low orbit satellites at just 200 to 300 kilometers, high-altitude drones or balloons, even sub-sea cables, all forming one integrated, resilient network. But the catch? The economics have to work. Rassvet's budget is about 450 billion rubles through 2030, with global coverage projected from just 400 satellites, if they can clear the technical and financial hurdles. So why does it matter? Because for Russia, Starlink isn't even an option, politically or militarily. Digital sovereignty, national security, and economic leverage are all in play. The real stakes: who controls tomorrow's sky? Let's drill down. What can we actually learn from these two radically different strategies? It's not about copying, it's about innovating within your constraints. Starlink's real genius wasn't inventing something totally new. It was scaling up decades-old technology, automating launches, and seamlessly integrating systems on a level we'd never seen before. Think about it. Starlink satellites use tech concepts proven back in the 80s and 90s, but SpaceX made them cheap, fast, and global by the sheer force of numbers and manufacturing muscle. That's where the so-called revolution happened. But Rassvet? Rassvet is taking a totally different path. Russian engineers didn't try to out-Starlink Starlink. They designed for higher orbits, fewer satellites, and bigger, more powerful platforms. The result? Each unit does more, and the system can work hand-in-hand with drones, high-altitude balloons, even underwater networks. And with direct-to-device 5G NTN on board, there's a chance for regular phones to connect straight to orbit, a potential game-changer in both civilian and military communication. The stakes are huge. For Russia, building its own satellite internet isn't just about business. It's national security and strategic independence. With Starlink shut off to Russian users and Western satellites off limits, having a homegrown network isn't optional. It's critical. But here's the risk. the cost is massive, and the rollout is slow. Will Rassvet's bet on quality and advanced integration pay off, or will the world move on to something else before it's ready? Is Starlink's more is more approach the only way, or can Rassvet's smarter, not bigger model set a new standard? And that's the lesson. Real innovation often means solving the right problem for your needs, not just following the crowd. If you're in tech, business, or strategy, ask yourself, are you chasing scale or designing for your own strengths? Miss that, and you miss the real drivers of progress. So as the global satellite race accelerates, here's what you should be watching for next. Does betting on fewer, smarter satellites trump brute force scaling, or is it a risky gamble? When you peel back the headlines, it's clear. Russia's Rassvet project is more than a Starlink copycat. It's doubling down on a radically different vision: quality over quantity, strategic autonomy over global dominance. But is that a bold calculation, or a high-stakes risk that could backfire? Here's what's at stake. Decoding these tech bets isn't just academic. The way satellite internet takes shape determines everything from national security to economic opportunity, and even who controls the world's information pipelines. For Russia, Rassvet isn't just a commercial play. It's a critical military and strategic backbone, especially as Starlink's access is cut off and Western networks are off limits. With only 350 satellites planned at 800 kilometers up and cutting-edge integration like 5G NT on board, Rassvet is racing to close an 8-year gap set by Starlink's relentless mass production. So, what do you think? Is this bet on fewer advanced satellites a masterstroke of engineering, or will it cost Russia dearly in time and money? Will 5G integration set the new standard, or end up as a luxury nobody else can afford? And can Rassvet truly catch up, or is the gap already too wide? Your perspective isn't just a comment. It's part of the bigger conversation about who wins the future of space, tech, and sovereignty.